We now move on to the issue of representing entity relationship models with diagrams. We will start with the most basic scenario, which is instructor advises student setup, and the way these are done is rectangles represent entity sets, so entity set instructor, entity set student. The title of the entity is distinguished from the remainder of the entity, the attributes, the primary key, etc. Anything additional that is distinguished, typically just with a line. The blue underneath here is nice for visibility, but typically it's just a line to separate it. Diamonds are used to represent relationship sets. The attributes are listed below the line for an entity set, with the primary key being underlined. If there are multiple attributes forming the primary key, then multiple attributes will be underlined. Entity sets with composite or multi-valued attributes. So here's the full details of the instructor entity. It has, of course, the ID, the name, the address, phone number, date of birth, and age. By the way, side note, no rational database design will include both of those. That is silly. And a better database design would include date of birth but not age, because age changes every year where date of birth stays the same. Composite attributes. Composite attributes are indicated by indentation, and in the case of composites within a composite, multiple levels of indentation. Multi-valued attributes are indicated by the use of curly braces. Nice, but there's a lot that's missing from that, so I've added some slides to clarify some additional issues. What if there are multi-valued attributes in a composite? What if there are multi-valued composite attributes? And what if there is some mixture of composite attributes with single and multi-valued attributes in the composite? So by way of example, we might have an attribute contact methods, which includes multiple separate phone numbers and multiple separate email addresses. This illustrated here, obviously with random phone numbers and addresses, email addresses, that is. A multi-valued composite, I might have two separate addresses. So I live on Fake Street in Newtown, and I have a cottage on Muskoka. Multiple values with single valued composites. The single values are simply indented as expected. The multi-value is identified by the curly braces. And then a blend, multi-valued address, and in this particular context, the street's unique, the province unique, the city has different names. This particular address, you might think this is fake. This isn't actually fake. I lived at this particular place for several years, and it goes under three separate city names: Toronto, North York, or Willowdale. Any of them will get there. So there can be mixtures of single values and multi-values within a composite. And this is obviously just a random separate address. Okay, descriptive attributes. Entities have attributes. Relationship sets do not have attributes. Well, they don't have them in the diamond. We can add descriptive attributes by attaching the attributes in a rectangular box connected via a dotted line. I will often make this also a dashed line, a dotted line. These may be multi-values, so let's imagine changing this relationship to meets with. An advisor meets with her students, and then we have a date. It needs to be multiple value dates. So, date. We can have multiple values. This is generally undesirable. When you meet with a graduate student, or imagine any meeting, your manager, employee meeting, whatever, we would have a date and a location. It might be tempting to do this, or maybe there's a single location. If there's a single location and multiple separate dates, you kind of have a mess. The better thing to do is to imagine a situation in which the location for a meeting is specified separately for each meeting, and then your multi-value attribute is, I'm simply giving it the name DL, multi-value, and it consists of a date and a location. If you are going to have more than one attribute, make sure they're tied together. If they are not tied together, if they are for some reason not connected with each other, then you should probably be rethinking your design. Having multi-valued attributes that are connected, multiple attributes as multi-valued attributes, or even as single attributes, if they are connected together, you probably are okay. If they are separate, and so you have distinct separate attributes that cannot reasonably be put into a composite, you should probably be rethinking your design. Roles. So entity sets can be connected to themselves, and in fact probably the best example of this is a person set, maybe social insurance number, name, whatever, would be parent-child relationship, for example. Or, again, person and married to. Okay, two separate roles. Well, in the case of married to, it's the distinct aspects of the roles aren't really relevant. So these happen to be distinct, and it's important to think of them as distinct because of the nature of a prerequisite relationship. So in this particular case, a course may have prerequisites, and so we identify one as the course and the other as the prerequisite. And the combination of the course ID and the prerequisite ID will be the superkey of prereq. Traditional cardinality constraints. So cardinality constraints are expressed, at least in this textbook, and the terminology varies unfortunately quite a lot, but in this particular textbook the terminology is that if there is a directed line to both entities, it is a one-to-one relationship, which means the instructor is in the relationship 0 or 1 time, and the student is in the relationship 0 or 1 time. So this expresses the idea that a student can have an advisor, does not have to have an advisor, but may have one advisor at the most. An instructor does not have to supervise a student, but if the instructor does supervise a student, it is at most one. A one-to-many relationship. Now, in this particular case, we've got the one on the instructor, at most one instructor per student. This is precisely why I do not like this terminology at all. Okay. The student is constrained to 0 or 1 instructor. The instructor is unconstrained and may have as many as they wish. An instructor-to-student relationship, a many-to-one relationship, this is just nothing more than the inverse of this. And in this particular case, it is at most one student per instructor. So the instructor is now constrained, to at most 1, and the student may have as many advisors as they wish, including 0. And the final case, many to many, there are no constraints. And although it's described as many to many, it would be better to describe this as no constraints. And the reason it would be better to describe it this way is then you can understand why there's no arrows. This is simply saying there are no constraints specified. Better cardinality constraints. In my experience, it is much better to think of the relationship between the instructor and the relation in the sense of the instructor can appear in the relation a lower bound number of times and an upper bound number of times. The student in the relationship can appear a lower bound number of times and an upper bound number of times. So this, in this particular instance, is saying a student can be in the relationship once or twice. So if we have an advisor's relationship, we've got an instructor, we've got a student. The student ID for any given ID, let's say it's 1, 2, 3, can appear once, it can appear twice, it cannot appear more than that. So this particular specification is the specification you would have if you say a student is required to have at least 1 advisor. Why at least 1 advisor? Because that is the lower bound. The lower bound is specified as 1. The student can have at most 2 advisors because that is the upper bound. So a student must have an advisor and may have no more than 2 advisors. A faculty member is not required to have any students they are advising, but if they advise students, they are limited to n students. And n is a parameter of the design. Okay, this is important. N is a parameter of the design. If we want to say an instructor can have an unlimited number of students, we will use asterisks. Asterisks is unconstrained. Participation of an entity set in a relationship set. Again, we're talking textbook terminology. The textbook terminology uses a double line to indicate total participation, or more precisely, it is required participation. Okay. The student is required to have an advisor. As far as I'm concerned, that's covered trivially by simply saying the lower bound is 1. And you'll notice in this particular case, there is no specified upper bound, and so that would be 1 to star. And this would be 0 to star. No upper bound, no lower bound. Okay, so this is the textbook way of describing it. The way I would describe this would be 0 to star and 1 to star. What if we have 3 entities in the relationship? This is the point at which their wonderful little diagram notation falls to pieces. They can't do it. They can't even express it. Suppose they say this is that. What does that mean? Does that mean an instructor has at most 1 student, a student appears at most once in a project, or at most once with an instructor? It's ambiguous. The issue is, what's the connection between the student and the project? What's the connection between the student and the instructor? What's the connection between the instructor and the project and the instructor and the student? And of course, what's the connection between the project and the instructor and the project and the student? And we've already seen how those are expressible using the better approach. Generally, you would not, by the way, express the cardinalities in the diagram, but you could easily express them within the design doc associated with the diagram. So you could simply say instructor to student is 0 to star. Instructor to project is 0 to star. Instructor doesn't have to have projects, doesn't have to have students, is unconstrained in how many they have. A student to instructor is 1 to 2. A student has to have an instructor, may have at most 2. A student, for the sake of argument, a student is required to have a project and precisely one defined project. And one could have the notion of a project with respect to an instructor must have a defined instructor in charge of the project. And a project to student, the project is not required to have any students, could have many students. Okay, one could imagine things like this. And this type of notation, there's no reason why it has to be in the diagram. There's no reason why it has to be next to the diagram. But it is useful if it is spelled out somewhere in a design document that is associated with the diagram. Weak entity sets. The existence of some things is predicated on the existence of other things. Okay, first of all, what do we mean by that? This does not mean in a causal sense. Your existence is predicated on the existence of your parents. We don't care. Not in this context. Not relevant for the context. What it means is the existence of something has no meaning without the existence of another thing. For example, if we want to offer a course, so what do we mean by offering a course? When we are offering a course, we have a designated time, a designated location, a designated instructor. This may be sufficient. The point is we have some key aspects that have to be specified. In order to define a course, we don't need any of those things. To define a course, we need a title, we need a description, we may need credit weight, how difficult is this course, we probably need a course code that indicates the number of the course, etc. So a course is in some sense of the word an abstract thing. It exists without ever having to have been offered. An offering of a course requires that abstract thing, the course, to actually exist, though. Now, that's a little bit abstract, a slightly less abstract. Imagine you talk about the sales figure for a car. A Toyota Corolla. In order to talk about the sales figure for a Toyota Corolla, maybe the sales figures are by month, by quarter. So sales figures might be month, year, location, etc. But sales figures for what? 2014 Corolla, Mazda, 3, whatever. The existence of the sales figures depends on the existence of what it is that's being sold. If you want to return a car, you have to have rented the car in the first place. If you haven't rented the car, you can't return the car. So the return of the car requires the rental of the car. In such cases, we describe the dependent entity as the weak entity, and we describe it as weak because it cannot be specified on its own. It must be specified with reference to some other identifying entity set, and let me be clear about this. That other identifying set might itself also be a weak entity. it's not necessarily a weak entity. It could be, and the term strong is sometimes used, it could be a strong entity in the sense that it is not dependent on any other entity. So in the case of sales figures for a car, it probably just depends on the car. In the case of the offering of a course, it depends on the existence of the course. But in the case of the car rental, it requires that you have rented the car in the first place. In the case of the rental, you may have a pickup relationship. You pick up the vehicle, so dropping off the car depends on picking it up, but picking it up might also be a weak entity, and the picking up entity could be dependent upon the existence of the car to be rented. So we refer to these again as weak entity sets, and in particular a weak entity set is, if you want a very formal definition, it is one that does not have a primary key solely on its own attributes. So how do we specify a primary key for the weak entity? The primary key for a weak entity is a combination of a few things. It is the primary key of the entity on which it is dependent, and those attributes in the weak entity set that, if we combine it with the primary key from the depending entity, the entity on which the weak entity depends, will uniquely specify every possible element in the weak entity set. These attributes are referred to as the discriminator of the weak entity set, and they are identified by underlining, but with a dashed line. So if something's underlined with a dashed line, you know it's a discriminator as opposed to an actual primary key. Excuse me. So the relationship between the weak entity and the entity on which it depends is typically identified by a double diamond. Technically, if you think about it, if you see an entity and it's in a relationship with another set, and we have attribute 1, attribute 2, and let's say this is underlined with dots. The fact that these are dots, that indicates it's a weak entity, but as I said, we will use a double line also. That is fairly common terminology, I believe. It has the primary key of the weak entity as the superkey. So notice, the weak entity set has a primary key that's defined this way. The relationship set, I should say the relationship set, has the same primary key. And that's important because what it means is when we have a weak entity set and the associated relationship, the only way that you could have separate tables for these would be if this had some attributes, and I'm fairly certain it would have to be multi-valued attributes. But we'll come to that later. So an example of a weak entity set, a library checkout record depends on the existence of the book being checked out. The book is likely checked out more than once. The book has a primary key, ISBN, plus library, plus copy number. So let us imagine a library in Kitchener. It has the Kitchener main branch, it has the Kitchener other branch, whatever. So we have a book, its ISBN is 43, and we have copy 1 and copy 2 and copy 3. And over here, ISBN 43 also has a copy. Copy 1, copy 2, copy 3. Probably, not necessarily, but probably these would actually be distinct, that you would not have the same copy numbers because people typically will deposit books. If you pick up a book at this library, you may deposit it at this library within the same branch, within the same city, But for the sake of completeness, assuming this has this as a primary key, a checkout record would have a discriminator checkout timestamp. So if I go along to check out a book, and we have a checkout record, we have the ISBN and the branch number and the copy number and the customer ID and the checkout time. So by time, I mean time and date, 12:03 on November 2nd, whenever. Identity 123, copy number 1, copy number 1, branch, Kitchener Other branch, ISBN 43. This, they're not in the checkout record. They're in the book record, or the book entity set. Okay? This is all that's in the checkout record. And these are discriminators, and so they add to the primary key. They're not sufficient for the primary key. And the fun part will have a return record that depends on the checkout record. So the return record is a weak entity that depends on the checkout record, which is a weak entity, which depends on the book, which is a strong entity. Notation for weak entity set. So again, the slightly annoying terminology here of this and this total participation. This is wrong. This is bad, okay? The textbook will claim that a weak entity set must be in a many-to-one relation. Okay, why is it in a many-to-one relation? Well, this entity will have duplicates in some sense. Let's consider the checkout. Suppose I check out that book number 43, okay, Kitchener Other branch, copy number 1. This is the book. Okay, this isn't the checkout entity, the checkout record. Okay, sorry, let's get this right. This isn't the checkout record is going to have ID and date. So let's say 1, 2, 3, and November 2nd. Let's say it's just the date. And let's say I return it, and then 2 months later I check it out again. So 1, 2, 3, January 2nd. So fair enough, these have occurred many times. Okay. And they have to be in this relationship. A library user checks out books. Fair enough. A library user checks out books. But this isn't the primary key. This is the discriminator. If we think about this entity as having a primary key that consists of the book primary key plus the checkout discriminator, that will uniquely identify it. And that goes in this relationship precisely once. I checked out book number 43 from the Kitchener Other branch, copy number 1, on November the 2nd. That's it, just once. So, that is a fairly key point. However, it's also wrong for other reasons. There's no reason for it not to be one-to-one, as opposed to many-to-one, even under its own terminology. A rental drop-off, like a library book, is a weak entity that's dependent on the rental pickup, but you don't return your vehicle or your book or whatever twice. You return it once. So it does not have to be many-to-one, even under that sense. The primary key of the weak entity, again, means the relation is exactly once. It's in the relation exactly once. It is the discriminator that's in the relation multiple times, or potentially in the discriminator multiple times. And the primary key of the identifying entity, this little beast, this is described as in the relation once? No! This is in the relation many times. What would be the point in describing a course if it was only ever offered once? What they're trying to say is that a given section should identify one and only one course. Okay, if we use this nice little XY notation, everything becomes a lot clearer. The course has a 0 to star cardinality. What that way of saying it means is the course may never be offered. If it is offered, it could be offered an arbitrary number of times. The section, it has a 1-to-1 cardinality. Any given section is in the relationship exactly once. And what that means is the section is with the course ID and the section ID, the semester, the year, that is once. It has to be there. If it isn't there, it wasn't offered. So this is section or course offering. Go back to the library. If a book is, if a book, let's call it checkout, ID, and date. This is the ID of the user, not the book. Okay, these are, I should make sure this is clear. I shouldn't underline these because that's going to cause confusion. These are discriminators. If I check out a book, which has ISBN 43 and everything else, if I check it out, me, on 2nd November, then it's in the relationship exactly once that I check this out. If this isn't in the relationship, then I didn't check it out. So by virtue of checking it out, I am in this checkout relationship. By virtue of checking it out, no one else is checking it out. It can be in the relationship only once. It is only if you pretend that the discriminator is somehow identifying the entity when it is not, that you can pretend that this is a many-to-one relationship and it's showing up more than once. But I would think, I do believe very strongly, and it will become apparent when we convert weak entities into relations in a relational database, you will find that this terminology is the way to do your terminology. And so finally, the textbook has an entity relationship diagram for the university. That particular entity relationship diagram is, of course, using their terminology. I would argue at the very least that it's very bad the way they've done it, and the way they've done it is they've insisted on using binary relationships. In fact, if you look, I don't think there is any ternary relationship in the set at all. No, there isn't, just looking at it. And that reflects the author's bias that they think that everything should be done as binary relationships. Well, let me tell you something. If you offer a course, if you have a section, it needs a time slot, it needs a classroom. These are tied together. This is bad. This is very bad. So they've messed up already there. They've tried to cover it by making them required participation, but again, they haven't even tied them in as weak entities. Okay, so the better way for that to have been done would in fact be to have section, classroom, so section, classroom, and time in a ternary relationship, because, and that combination for various reasons we'll see later, connected to a course offering, and I'll show you how to do that a little later. The problem with this setup is you could have a section that's specified as being in a classroom and a different section that's specified as being in the same classroom at a conflicting time, or the time may not be available because they have not tied these three together. That's enough for this particular component. I will continue in the next lecture with design issues for how to deal with design choices.